right. So the title of this session is basically configuration management comes to Windows. So if you ask me a question, what happened configuration management on Windows all these days? You had Puppet, Chef, CF Engine, and many others doing the same job, right? To some extent, your System Center Configuration Manager, or to some extent, Operations Manager, such tools have also done the same thing. So in the most recent release of Windows operating system, Microsoft silently built a new capability, which is called desired state configuration. Okay. How many of you are Windows administrators? How many of you work on Windows? Okay. So my next question will be, how many of you know what is Windows PowerShell? That's very good. Okay. For the rest of those folks who don't know what is Windows PowerShell, it is an object-based distributed automation engine. Okay. When we say object-based, many of these shells that you have seen, like Bourne shell, Corn shell, for the matter, cmd.exe is also a text-based shell. Whenever you deal with a command's output, you basically go parse it, and you go convert that text into some whatever different type value that you want, and then you kind of manipulate that value, and then use it in your scripts or applications, etc. Windows PowerShell is completely based on .NET. It's written on top of .NET, so it understands all .NET types. It can talk to Win32 native APIs. Okay, so everything that you see in Windows PowerShell is an object. Let me quickly show you one example of that. For example, if I have something in my www root, I just want to recurse. What I really want to do is I want to get a size of all the files within the root web folder that I have. So how would you do that in a cmd.exe? You basically do a dir, get the length column, and again convert it, like I said, into integer and then count it. I mean sum it basically and then output the value. Whereas in PowerShell, the way we do that is, I have a property called length, and I just do a sum of it. Right? And when I do that, this is what I get. So that's the total length of all the, size of all the files within the www root folder for me. Right? Now, if I want to convert that into, for example, kilobyte value. Sorry, it's doing it my. I just do a 1 KB, it gives me 181 KB, which is this total size of the folder here. Okay, so that's Windows PowerShell, and it has a lot of other capabilities, like it can do, like when I said distributed automation engine, it can do workflows, it can do PowerShell remoting, you can sit at one console and execute commands the way SSH does, or you can do a fanning remoting where you have multiple systems talking to a single system. This is more in terms of, let's say, cloud-based environment, etc. Right? So why PowerShell today? I'm talking about DevOps and desired state configuration here. So whatever I'm going to show you today is all mostly based on PowerShell. Okay. So desired state configuration is a feature which is an operating system feature, but to leverage it or use it in the data centers to apply configuration, etc., you would require PowerShell to a large extent. Okay. So if you know PowerShell already, it's a piece of cake for you. Okay, I don't want to reiterate the importance of DevOps or continuous delivery or configuration management within the data center, right? We all understand that's why we are here today, right? But just to reiterate a few points here, we want continuous delivery, service delivery, because I don't want any interruptions in my service. I want like maybe 5 nines or 6 nines or whatever it is. I want a rapid release cycle. For example, those people who know Windows world, there are a lot of patches coming in every Tuesday. Every first or second Tuesday of every month. It's called Patch Tuesday. And you have a lot of people still think there are a lot of security issues and there are security patches coming in, and you have updates that you have to manage, etc. Right? So I really want a streamlined and seamless release cycle for any of these updates that I want to do for my infrastructure. Okay? Again, continuous deployment of those update patches, etc. So this is what I really want to do with respect to configuration management. And also from a service delivery point of view, For creating a DR scenario kind of a thing, I want the exact configuration to be replicated onto different systems. I don't want any configuration drift as such. So any configuration drift basically means my DR capability is lost. Okay? So I have a system, primary system, which is having some n number of configuration changes made over the time. And if I'm not able to replicate these changes in an easy manner to a DR side, I'm a failure, right? Basically, when I want to do the real disaster recovery, nothing will actually work because some of the configuration changes that have been that were done on the primary system are completely lost now, right? So that's another important aspect. And automation definitely plays a role there. Windows PowerShell is something that is integrated into the operating system. It is the default management shell for many of the Windows products. And of course, there is a lot of cross-platform integration that is happening now through Open Manage Initiative and SIM and other aspects, right? So you can actually create SIM profiles on a Linux machine using OMI, and then use Windows PowerShell to manage your Linux and Unix hosts as well. Okay. So automation plays a very key role, and that's where Microsoft invested a lot of money in creating this desired state configuration, which is I wouldn't really call it a competitor, but it's a technology that complements Puppet and Chef and like others alike, right? Alright, so desired state configuration, it enables you to ensure the components of your data center have the correct configuration at any point in time. It prevents configuration drift. Okay, there are multiple ways of doing that. So Microsoft invested in standards-based management. So this is all based on WMI SIM that we all know already, right? We use WMI SIM more or less every day in the Windows world. Okay, and it is based on whatever PowerShell knowledge you already have, right? So if you know PowerShell already and how to write scripts and how to use PowerShell, you know how to write these configuration documents or recipes in the other words, etc. Right? Now, how do you get it? There's a catch here. It comes built in with Server 2012 R2 on Windows 8.1. You can also get a package called Windows Management Framework 4.0, which is downloadable free of cost. You can install it on Server 2012, 2008 R2 and Windows 7. Okay. So a desired state configuration is now supported on all these operating systems. At the down level, you will not have any support for it. For example, Windows XP, Windows Vista, Windows 2003, 2003 R2, desired state configuration will not be supported. Some basics to start with. Does that ring some bells? Looks familiar? This kind of a syntax? No? Okay. So PowerShell by its very nature, it is imperative in nature, right? For example, we tell PowerShell how to do things. Okay, you write a 100-line script and say, this is how I want to do something to achieve something. So you have a task in mind, and you break that task down into multiple steps, and you script that in a 100-line or 200-line, whatever script it is, and then you say, this is how I want to achieve a task. That is imperative in nature. For configuration management, that wouldn't really scale well, right? So if you keep writing, for every change that you want to perform on our infrastructure, if you keep writing hundreds of lines of code, at one point in time it becomes completely unmanageable. Okay? That's why Microsoft chose to implement something called a declarative syntax. Okay? If you actually see within this syntax here, configuration is a new keyword that is added to the language, which basically defines a configuration document. And this is just the name that we can give. Any name will do there. A node basically identifies a computer where this configuration will be applied. Okay? Archive that you see here is a resource name. Think of it maybe like, I don't know what they call it in Puppet or Chef. It's a provider basically, right? I have a provider which basically understands how to apply this configuration on a target node. And this is just a name of that resource. And these are the different attributes that I have for this particular resource now. Okay. At the end of it, I just call the configuration. It creates a MOV file, which is a managed object file, managed object format schema basically, which is should be very familiar to people who worked on SIM. And Using PowerShell remoting, we can actually send that MOF configuration to a target system or a set of target systems and apply it there automatically. Okay. Now let me quickly show you what exactly it looks like. So for those of you who have not seen, this is the PowerShell ISE, which is a script editor. It has the same Visual Studio IntelliSense capabilities and etc. So we can actually run one of this. Let's try. So this is what I have there also. I have two servers. One is my Windows Server 2012 R2 server here, and there's a client system which is Windows 8.1. So let me run this. It generated a MOF file for me. I just go into the archive, say Notepad. So that's how a MOF file really looks. So if you know how to generate these MOF files, then you don't really have to go through a configuration document also. You can directly author a MOF file and then apply it to a system, target system. Okay. Essentially, what it basically says is all of this. It's an instance of this resource that I have, which is the resource Microsoft has built in, right? And the resource ID is written here, whatever string that you provide there, and different attributes are taken in here automatically. And also at the end of it, you will say this is an instance of a configuration document and who generated it. So this is my server that generated the configuration document and author time, etc. Right? That's a very simple notation. If you really want to generate MOF files yourself, you can actually do that. Or if you write a tool that generates these MOF files based on a specific configuration or a topology, you can actually do that yourself. You don't really have to go through a configuration document to do all this. Okay? So that's pretty much it, right? This is it. I mean, your site. Basically, you create a configuration document, you run that configuration document, and there's a commandlet called start-dsc configuration. You point that commandlet to the MOF file that you just created. It goes and applies the configuration over the wire. Okay. It's called push configuration. We'll basically look at different delivery mechanisms also in a bit. And Microsoft also created some built-in resources to start with. Okay. For example, these are all the built-in resources Microsoft already has within the DSC feature. So I can use archive to go extract files, etc. to a remote system. I can set environment variables. I can have a file resource which does basically copies of folders and files to a remote system from a network share or whatever. I can have group which basically creates local groups within the computer, I mean the user groups, etc. And you have log that you can use to log messages in the Windows event log. Okay. Package, you can use that to install MSIs or setup.exe based packages. You can remotely install all of them. Process, deal with Windows processes. Registry, everything and anything in Windows is basically a registry entry, right? So you can play with registry directly using the registry resource. Role is specific to Windows Server operating system. You can install roles and features using that. For example, if you want to install an AS server role, you can actually install that using this resource. Script is basically anything that cannot, something that cannot be done using any of the other resources. You can just code yourself. You can write a script resource and say, go execute this script resource on remote systems. It's like exec in some of those other Puppet and Chef kind of configuration management software, right? Services, you basically deal with Windows services. User, of course, it's local users, right? There's nothing to do with Active Directory users. When you use that particular user resource, it creates and deletes local users or manages local user accounts. Okay, and of course you can build your own resources. Like I said, all you need to know is Windows PowerShell. If you know Windows PowerShell, you can write your own resources. And it's not mandatory. If you are a .NET programmer, again you can write your resources in C# and then use them as DSC resources here. Okay. So let me quickly show you this. Let me execute and see. I'll show you how exactly it works. So now we executed this, I think. Right. So I use something called start DSC configuration. I point to the folder where it is now. I say archive resource demo, and I want to see what messages I get from that. I say wait. Okay. Okay. So what you essentially see is what's happening behind the scenes. Okay. Every resource has three different functions. One is a get function, which basically tells you whether that particular configuration is already applied or not, a get target resource. And you have a test target resource function, which basically tests whether whatever configuration document you are trying to apply is already present or not. Okay? And the third one is this set target resource. When test returns false, set goes and applies the configuration. Okay, that's what you exactly see in the verbose messages also. Alright, so the first it is basically checking if the destination file c:\scripts, which is a folder, is existing or not. Basically says it's missing. It's not a file, right? You have to create a folder. So it is looking for this particular demo.zip, which I copied to the same machine. I could have done that from a UNC path also. It took that, it actually unzipped it, extracted it at c:\scripts location. Okay, so that's it. It basically checked first whether it exists or not. c:\script doesn't exist. It goes and creates c:\scripts folder. It takes the zip file that I have in c:\backup folder, extract it down there. You go there, should be able to see that. So if I go, scripts folder is created, and that I have the demo archive unzipped there. Okay. So this is very similar. I mean, for any resource that you have within DSC, the syntax will be very similar. And if you don't know how to use a particular resource, what you can do is, like I said, ISC supports IntelliSense. Just highlight this or click here and do a control space. It gives you the different that's weird. It's completely weird. Let's say one more time. So like this, right? So what are the different attributes supported by that particular resource? It actually shows you all of it, which is mandatory. Anything that is in kind of a square brackets is kind of optional thing. Everything else is mandatory that you have to provide that attribute. Okay. And like here, like any other configuration management framework, ensure attribute basically tells you whether to apply the configuration or remove it. Okay. Then when I set it to ensure present, it goes and sets the configuration. When I say ensure absent, it basically checks if the configuration exists, and if it exists, it goes and removes the configuration from the target system. Okay. And of course, you can have multiple dependencies also created. For example, you see this. I'm creating a dependency here. Like this particular attribute basically says depends on this resource. So when I execute this, what it basically does is it goes and checks first that user exists or not on the remote system. If the user exists, it will go create the group and add the user as a member to that. If not, it will go create the user first, then create the group, then add the user as a member to that. Let's see if this works for us. So basically I need to provide the test user credentials because I'm creating a new user. I'll just give it a username and password. So I have this start DSC configuration again. Say wait hyphen. Okay. So it is now applying the configuration. As you see, author user group demo was the first resource that we have in the configuration document. It found that there is a dependency. It went to the user demo. It first looked at whether the user exists or not. and then it went to the group demo, and then it created the group, then added the user. Okay. So those kind of dependencies can also be created within the configuration documents within DSC. Okay. Now, writing custom resources. This is like I said, again, not very tough if you understand the exact flow, how it has to be done. What you have to really do is create a mock file first describing your resource. Every DSC resource has to be an instance of a base class, a base resource that Microsoft has, and then you create these three functions within your module. You basically create a PowerShell module, which is a .tsm1 file, or you might want to create a, let's say, C# binary commandlet module or whatever it is, and then add these three functions in it. And you have to ensure that the set target resource is idempotent, right? Any number of times I apply this configuration, you should come out clean, and you should not generate any errors out of it. Okay? The configuration already exists. You are trying to apply the same configuration. You just silently exit out of it. Okay? You should not create errors during that process. So that's what the last point really means here. Okay? And we'll also see that how exactly those functions are created. And then you just copy all those files to this particular path, or you put it in your own custom path. Do I import DSC resource? Okay. This is the actual module path. If you see, most of the Microsoft modules are there. So you go to modules and PS desired state configuration. You'll see PS providers. And these are all the built-in modules that Microsoft has already. And the host file is something that I created for the demo purpose. Right? You can go and manage host files using that, which I'll show you in a minute.
So it can be dynamic in nature as well, like configuration like GFS or subversion and
right.
take it from there.
Yes. I'll talk about that in a bit. That's a configuration delivery aspect of it. We have two models there. By default, it is always push model. So you push the configuration to the target node. There can be a pull model where the target node pulls the configuration of the modules that are required. That is also possible. This is something I already showed you, right? This is just a MOF file which describes all your attributes, etc. For example, for the host file resource that I created, I had only two attributes, which are key attributes, host name and IP address. Key basically says that it's a mandatory attribute. Okay? And I have a value map here, which is created for the attribute ensure. The possible values I can put in this value map here, present and absent are the possible values of that. Okay? So only these two are mandatory. Ensure is always set to present by default. Okay? It tries to go set the configuration on this, unless you specifically say ensure equal to absent. So that's why this particular attribute is optional here. Okay? And then once you have that, you basically give it a name, your resource.schema.mof. The schema.mof is mandatory. Okay, you basically give that naming convention to that. And once you have that, you start working on the custom resource module. Okay. So there are some constraints here. You have to create three functions with the same name that you see here: get target resource, set target resource, and test target resource. The get should always return a hash table. Okay. For example, in the earlier example, I had a host IP address and a host name. When someone does a get target resource for the particular host file resource, it should return a hash table of the contents of whatever logic that you have. For example, in my case, it will return all the entries that are there in my host file as a hash table, IP address and a key value pair basically, right? It basically gives me IP address and the host name. So that's what the get target resource should always do. Set target resource, again, there are constraints I'll talk about in a bit. This is where the actual logic is, right? It sets the configuration, it applies the configuration. Test target resource, it should always return a Boolean value, a true or false. Okay, because set target resource functionality really depends on test. Only when test returns a false, set goes and changes the actual configuration. So that's a very critical thing. And also, if you are not coding test target resource properly, there are chances you might make a system unusable completely. I'll tell you one scenario where it really happens. Module manifest is a requirement, so you can use a PowerShell commandlet new module manifest that actually generate a module manifest for you. Manifest is nothing but a data file. It always ends with a .psd one. Basically describes your entire resource or the module itself. For example, in my case, you should see. So this is my a manifest. A manifest basically says what are the different members that I want to export, and some optional things like there's an author, company name, copyright, and different other things. So a new module manifest automatically does that for you. Okay. Let's quickly see this. So this is the module I created for the host file management. Now using this module, I can actually go change host file entries on different target systems, right? So what I have, let's first go to test target resource and see what I have here. It's a simple logic. What I'm basically saying is, see, by the way, the parameters have to be always same across all the three functions. You cannot have different parameters in get target resource and different parameters in set target resource, etc. Right? This block has to be same always. And once you have that, I put an exception block, and I'm saying if that file exists, look for the entries in it. Okay? I'm using a simple regex there, where I basically split that based on some space, etc. And it's not a commented line in the host file. I just check for that and convert that into an object. Right? So once everything is done, we just return that. For example, entry exists. Someone is already telling, someone has given a configuration where hostname 1 and IP address 10. It should not exist, right? But if the entry exists, this logic here basically checks and says, yes, it exists, but whereas the configuration document says it should not exist. So it returns a false for that. Okay. Once it returns a false, basically set configuration knows how to go remove that. It goes and removes that particular entry from it. The set target resource again has the same kind of a logic where I go check the content of the host file, and if my test target resource basically says that I have to remove an entry or add an entry, I just go do that using simple regex methods again. Right? And the get target resource is what you have to see. Right? So by default, I created a the hash table here, which is configuration hostname and IP address. What we are doing here is we are checking if the host file exists, and then adding the value. If the entry that I'm looking for exists in the host file, I'm just adding a value there, whether ensure is present or absent. Okay, based on the existence of the key pair or not. Okay, and I return that configuration. And as you see here in PowerShell, this is a hash table, right? And I just return that hash table. This is what get target resource is expected to do. So once you have all these things, I copied all the files to whatever location I mentioned, and you're good. Now then we can basically start creating a configuration document like this, which goes and edits the host file on remote systems. So in this case, what I'm actually doing is I'm adding one entry, and I'm trying to remove another entry if it exists. Okay, so let's try this. So if you see for the second configuration resource that we had, basically says checking if the host file entry exists, and it then says in the configuration document it is set to absent, but in the actual host file entry on the target system it exists. So it basically says the host file entry exists while it should not exist in the target system. So it goes and removes that. So that's how actually the whole DSC flow happens, execution flow. Okay, I think I have a slide to show you that in an easy manner. Yeah, this is the one. Okay. So you have three functions. Test, target resource, and set are the most important. So if set target resource returns true, it just goes to the end. It doesn't apply any configuration. Only when test target resource returns false, the set target resource is called. Okay. So test target resource becomes a very crucial, very essential, piece of logic in the whole resource that you build. Okay. If you are not doing a good job there, you'll actually, like I said, there are a few things like if your configuration, whatever you are trying to apply, requires a reboot. You can tell the desired state configuration engine to go reboot the system automatically. Okay, that you can indicate by using a global variable called DSC machine status. If you set it to 1, the moment DSC engine finds that DSC machine status is set to 1, it will go reboot the entire system automatically for you. Okay, and the entire DSC configuration restarts or resumes after that. Resumes after that automatically. Okay. So if your test target resource is not doing a good job and it's returning false for some reason, it will go into a loop of reboots and you'll never be able to recover that system. Okay. Since the DSC machine status is set to 1, a set configuration always tries to apply the configuration. It goes into, it keeps setting DSC machine status equals to 1, and then your test is failing to return the right value, it goes into the reboot loop. It won't even let you log in. Okay, the moment it comes to the login screen, it will reboot again. Okay, that's a kind of a risk that you have if you don't code your test target resource properly. Okay, I just talked about a DSC engine, right? So that's called the, there's a small kind of an agent that is running on the Windows servers after you install Windows PowerShell 4.0 or WMF 4.0. And once you have that, there's a local configuration manager that is responsible for looking at all your settings, the DSC settings, right? So these DSC settings can be like I said, you can configure it to push configuration delivery or a pull configuration delivery. And once you have that, this local configuration manager, you can configure it to automatically check at a regular interval whatever source location that you have mentioned for different configuration changes and apply them automatically or just report the audit, right? Whether the configuration is on par with the whatever source you have or not. Okay. So quickly I'll show you that. So I have only one client, so let me show you this quickly. So this is how we change the local configuration manager. Again, it can be a configuration document also. You don't have to really do it outside of DSC. Using DSC itself, you can change the configuration settings of our target node. So in this case, what I'm actually trying to do is configuration mode. I'm basically saying apply and autocorrect. It basically means it goes and checks the source server automatically, and if there is a difference between the baseline and what is there in the source, it goes and applies the configuration automatically for you. Okay. There's also apply and monitor. It applies for the first time, and the next time onwards, it keeps monitoring and reports any changes or any differences between the baseline configuration on the target server and what is there in the source. Okay. This is the one I mentioned, right? Reboot node if needed. By default, this is set to false. But if you set this to true, if a DSC resource is asking for a reboot, a DSC engine will just reboot the system. It won't even prompt anything. Okay. And this is the refresh mode. This can be set to push or pull. When I set it to pull, I have the choice of using two different download managers. One could be a file download manager, which can be from my SMB share, or a web download manager. It can be a REST-based web server that can give you this configuration. So by default, Microsoft gives you one DSC server, DSC pull server, which can be configured again using PowerShell. There's a particular feature in Server 2012 called DSC pull server, DSC server. You can install that feature, configure a website. If you want HTTPS SSL endpoint, you can create that, and you can dump all your configurations there, and then the clients can be configured to pull from that particular resource. Okay. Except the way we execute this again is very similar. It's done. Right. Now when I do a get DSC local machine configuration, now my configuration mode is set to pull. Okay. So there is a DSC server here. So we just configure a simple website. It's nothing. I mean, Microsoft provided all the web.config files, everything required for it, along with the feature. So all I have to do is just create this website and point to that route. So I have this DSC pull server here created, right? So when I do explore, it shows me what are the different files I have here. I can actually go to program files, Windows PowerShell, DSC service, configuration, and this is where I dump all the configurations. Now if you looked at the other thing here, I have a GUID assigned to a particular node. This node is not identified by its computer name, but it's identified with a GUID. And using that GUID, I can just create a MOV file and just copy it here. The next time the refresh frequency comes out, it automatically looks at the GUID, pulls the configuration, since I have set it to apply and autocorrect. Okay. This is basically how it actually works. By default, it is always in push, and the configuration is also calculated. The PowerShell parser, the parser and the dispatcher, they actually do all the job. Right? And this is the pull model, wherein you have the REST endpoint. That REST endpoint can be anything. You can create your own REST endpoint, because Microsoft opened up the specification for creating a pull server. So if you have your own REST endpoint, you can actually use that along with DSC engine also. Okay. Alright, that's all I had, and this is the summary, right? DSC basically provides a standard-based configuration management platform. Like I said, it uses same WMI, WSMan for remoting between the source and the target nodes. And you have PowerShell, which basically provides a seamless integration with Windows platform. So anything that you can do on a Windows platform, you can actually do it through Windows PowerShell. Right? So it becomes very easy to automate stuff on the Windows platform itself. But don't think that this is limited to Windows platform. The end goal is to make it work with heterogeneous platforms like Linux and others. Like I said, OMI initiative, the Open Management Initiative, basically looks at how to create sync profiles and make management of Linux machines from a Windows PowerShell console possible. So once that is in place, there are already people working on that, creating sync profiles for Linux, etc. Once that is done, you can actually manage your entire data center, whether it's Linux, Windows, or any other box, even a network switch or a storage box, etc. Everything from PowerShell console, and using DSC, you can actually manage the configuration automatically. Okay. That's all I had. And these are my coordinates. Sorry. Thank you. I said it's based on Windows PowerShell remoting, right? The configuration push or the pull happens over WSMan protocol. And within Windows, you require administrative privileges to go talk to a target server remotely. That's basically using WSMan, you require administrative privileges. Okay. So if your administrator account is compromised, your entire data center is compromised. So there's nothing that DSC push mechanism or the pull mechanism creates a whole kind of a thing. It's actually built on top of the existing security models. So if the underlying model itself is compromised, your entire stack is compromised. But otherwise, it's pretty secure. Yeah.
Ravikanth, how does it work with Puppet or Chef? How does it work, John?
Okay, so the pull model I showed you here, right? Third-party languages and tools, you can actually create your own server, or the configuration document is nothing but a MOV file. You can have a Puppet, I don't know what exactly they call it. So you can have that, or maybe Ruby or other places to go create those MOV files, generate those MOV files for a specific configuration on the Windows infrastructure, and push it to this source that you have, either the pull server repository that you have or the push repository you have. Just push it to that, and you will be able to manage things using Puppet and Chef automatically.
Does it work with Azure and all? And if I have a VM in Azure?
Yes. See, all it requires is an operating system, right? And that is supported. If it is Windows Server 2000,